I think I am live now. Can anyone confirm if audio and everything is fine before we get started for the today's post-contest discussion? Hello everyone. I think I am live now. Can anyone confirm if audio and everything is fine? Like we will probably wait for a minute or two so that schedule 10:30 starts and then we will get started discussing all the problems for today's one. Okay, audio is fine. Thanks a lot. Aryan, Soham, Shivam. Okay, probably just a minute more. Like, how was your contest? Like, how many problems were you able to solve, and on which problem were you guys stuck? Because probably that can help me decide like which problem to focus more and which to focus less. Mhm. Some of mode Q1, Q3. Like Q1, Q3 is a bit misleading because it also depends on the division as well. Okay, let me just test out if whiteboard and everything is working fine. Okay, only one solved. Q3 I solved only 1 second. XOR question and question sum of modes नहीं आया, lexicographically आया. You got it. Okay, I am like definitely I will explain all the problems. Like I am at a new place today and probably like I hope lag and everything would be fine. If it turns out to be SU, then I will probably order a writing pad. Looks fine. Okay, then let's get started. 136. This is the contest we would be discussing today. And let's get started now. So like let's start from the first problem. First three problems which were not rated for D1. Who makes P1 at this point of time? Like the first problem in CodeChef is always checking given two variables, check if x less than y, print something and otherwise print something else. And like the story literally makes no sense here. Tyro and Tom are fighting over who makes blah 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 and something like that. Let's just skip it. Let's just read another sample. It says if two integers are given AB, if both of them are equal, print Tyro. If x is greater than y, print Dom. And probably if you read the story, it would make sense that if x is less than y, then also print Tyro. So let's just read two integers x and y. If n is greater than m, print Dom, otherwise print Tyro. And like that was the story. Like it doesn't make much sense over here, so I will probably skip reading the problem statement. Like the next problems were slightly difficult rather than just different. Given an array A of size n, find the sum of largest subarray of A which has an even sum. For example, array 2, 1, 3, the answer is just 1. as the largest subarray with even sum is either this two or this two. If you take everything, like the sum is 5. If you take at least two number, one must be taken 2 1 or 1 2, the sum would be 3. So like 3 and 2 cannot be the answer. And then it says note that subarray is continuous part of the array. The array 1 3 5 has some possible subarrays this. However, 1 and 2 where you skip the element from the middle is not the part of the subarray. Given like t test cases and integers and a1 to an. So like what is the best answer we can get over here? Like first thing we can do is like we have a1, a2 up to an. If sum of everything is even, then we can say that the answer is n, because we cannot get an array more than the size n. So if we can get like sum of everything is even, then we can take the complete array and print n as the answer. Now let's say sum is odd. Then it must also hold that there is at least one odd number. There would be at least one odd number. And like the idea is like if you do odd minus odd, you get even back. So let's say like you have this as an array, even, odd, even, odd, even, odd, even, odd, even. Like let's say this is the array. There are 5 odd numbers. So overall sum is odd. And let's say if you remove this even number, then also the sum remains odd. If you remove this also, sum remains odd. If you remove this, sum remains odd. If you remove this odd number, sum remains even. Sum becomes even. So one idea can be like take these numbers, like remove everything until the first odd number. Or we can do the other thing as well. We can start deleting the last number. Sum is still odd. Sum is still odd. If you remove this, the sum becomes even now. So like the other possible choice is this. And the idea is like we can find like how many numbers to delete if you want to delete one odd number from starting, or how many numbers to delete if you want to delete one number from the end. And like that way, like we can subtract that from n and we would be good. So this is one solution, which is order n. By the way, like the constraints were really small. N was less than equal to 50, t was less than equal to 50. So we can try all subarrays as well. And like there are order n square possible subarrays starting and ending point. And you can also find sum of each of them in order n time. So overall order n cube is also allowed in this case. And like if you like probably maintain some running sum, then it's also possible to do it in order n square as well. And like this was pretty much the idea for this problem. So like what I did was like take n as input, find the sum of all numbers. If sum of everything is even, print n. We don't have to delete anything. Otherwise there are two cases. If we delete some numbers from starting, if x% 2 minus equal to x minus equal to 1 minus, like this can be the possible solution. As soon as you encounter an odd number, there is no need to do anything more. And like we can also do sum and like that is essentially doing the same thing, but we can revert the complete array. If we remove numbers from the end, and at last we can print the maximum of both the cases. And like this is the solution. Yeah, like, can you tell what is wrong with taking sum of array and then subtracting element from the last while sum is not even? Like, the problem is, like, let's look at this test case. 1 2 2 2 2 1 2 2, and let's insert one more one. Like, the overall sum is odd. If you keep deleting from the end, you will end up subtracting 3 elements. While if you remove from the starting, you will just delete one element. So like, this is maximum the length we can get. So like, you have to consider both the cases, when you delete from the last and when you delete from the starting, and take maximum of both of them. And like, that is the only case over here. So just starting does not work. You have to also consider when you delete from the end as well. So that was the idea. Like, I will probably move to the third problem then. It says we are given two-dimensional grid where you start at 0. We have given a binary string. It basically says there are 4 possible directions from each point. You can go up, down, left, right, and then you have a binary string. And based on the binary string, some directions are allowed, some directions are not allowed here. And now, like, it asks us to find, like, in the -10 to 10, like the complete grid, how many cells you can visit. There are multiple ways to it. Like, one of them is probably you can analyze all the possible possibilities here. Like, for example, only left can be present. In that case, you can go from 0 to -0 to -10, 0. If both left and right are allowed, then you can go any point on the x-axis from -10 to 10. And like, up also, like, there are can be many cases. The cases can probably be of, you can I only you can go nowhere, you can go only in one direction, or you can go to the complete axis, you can probably go to a quadrant. Like, there can be many cases. And like, one possible solution, as people pointed out, is to hard code all the possible possibilities there. And one more way we can do is, like, we can probably run a DFS algorithm as well, and see like what all cells we can visit. It might not be a possible, but yeah, we can do a DFS type algorithm as well. The idea is try all possibilities. Let's say we are at currently cell x comma y. Try all the directions we can go to. And like, let's say after going left, right, up, we have reached some cell. And if it's already, like, we can maintain a visited array or visited set consist of all the coordinates we have already seen before. So let's say, for example, when you were going via this direction and reached here, now when you reach this direction, you just skip, you don't try it again. And like, that should work for this test case here. First, I maintain like all the possible directions, and based on the given string, like, CD is my array of all the allowed directions here. And like, now, like, I can start a recursive DFS here, 0 0. Like, if I am outside the grid, return. Otherwise, if I have already visited this cell, return from here. Otherwise, insert this cell into my visited cells array and try out all the directions which we can go over here. And at last, print the size of set which we have visited. And yeah, like, this was the solution I ended up implementing. So like, yeah, like, there are way lot many cases, and I feel like these cases were allowed, and the only reason they gave this much test cases was they probably want to make it a div-free problem, so that if someone does not know, like, they can just look at these test cases and get away. Yeah, like, order one, like, there are only around like 2 to the power 4 16 possible directions, so you can always compute it offline and hard code the answers here, and that would be order one there. Or like, the other way to look at is like, the number of cells you can visit is less than 400 500, and visiting 500 cell in one go is also an order one, because whatever be the input, like, you just visit 500 cells at one point. And like, that was the idea for this problem. Any questions on the first three problem before we move to the problems which were rated for D1? Okay, so I will move to sum of modes. For a binary string t, f of t is defined as number of mods of string t. For example, f of 101 like is mod is defined as 1 as it has one unique mode 1, while f of 01 is 2 as it has two mods 0 and 1. Given a binary string s of length, and compute the value of mod of all the substrings of s. Mod of a string is character which appears with maximum frequency. If multiple characters have maximum frequency, all of them are said to be mod. For example, the string 111 has mod 1 while string 10 has mod 2 and both 0 and 1. So like what are the possible cases over here? So like first thing is we are given it's a binary string. So only 0 and 1 are the characters in the string. So either we have f of string which has only mode 0, or like the f of string can have mod 1, or f of string can have both mode 0 and mode 1. And notice that every non-empty string has at least one mode. Because if a string has some characters, then there would be some mods over there. And like essentially the idea is like either f of s is 0, like f of s is 1, like only 0 is mod, or only 1 is mod, or f of string is 2 when both 0 and 1 are mod. Looks fair, right? Like does this make any sense, or like the idea looks fine? Like mode cannot be more than 2 because there are only two types of character, and mode cannot be 0 because string has at least one character. So like the characters are 0 and 1. Only 0 can be mode, only 1 can be mode, or both 0 and 1 can be mode. So like these are the two possible values of f. And like once we know that, we also know like the total number of strings would be n into n plus 1 by 2. And let's say k is the count where f of s is 2. Then n into n plus 1 minus 2 minus k strings with f of them is 1, and k strings where f of something is 2. And now we can take sum of both of them. One into this and 2 into this, and we can add both of them. Like does this makes any sense? Okay, like value of f can be only 1 and 2, and like total number of strings is n into n plus 1 by 2, like total number of substrings of the given string. So if we can count like how many strings have value 2, then we can subtract it from total to count how many strings have value 1, and then we can take the respective sum and get the total value. So our problem reduces to count number of strings where f of s is 2, both 0 and 1 are mod. This can open like if we have a string s and count 0 is number of times 0 appears, and count 1 is number of times 1 appears. So if count 1 is equal to count 0, then f has mod 2, otherwise f has mod 1. So like the problem reduces to counting the number of strings which have same number of zeros and same number of ones. and like this problem has appeared quite a lot of time, and like the idea is like replace 0 with -1 and 1 with 1. Like, so example, let's take a given example. Like if s is 1 0 0 1 0 1 0 1. So the idea is if we replace 1 with 1, 0 with -1, 0 with -1, 1 with 1. Then if the subarray sum is 0, then the number of times 0 and 1 appears is same. So for example, in this string, like you can see like number of 0 and number of 1s are same. And you can also see like sum is also 0 here. So the idea is replace all zeros with -1, replace alls with 1. And now you have to count the number of subarrays which have like the sum 0. And those are the number of arrays which have mod both 0 and 1. Because like when you have a counter where if you increase if you get a 1 and if you decrease if you get 0, then like if number of times you increase is equal to number of times you decrease, then the end of the day you have the 0 value. And essentially that is the idea. Now once you know this, like there are many ways to do it. You can probably create a prefix array first and then count all the indexes where 0 appears and many idea. And essentially this was the idea. Like main crux of the idea was replace 1 with 1, 0 with -1. Count the number of subarrays which have sum 0. Those would be the number of arrays which have f as 2, and total minus this count would be the number of arrays which have f as 1. So like essentially my solution is also here. Like count 2. Like let's count the number of subarrays. Like it was essentially maintaining the prefix array. Like first we push 0 there. Like the number of times current sum appears, like prefix sum idea I was using. And that is the idea. And like this idea has appeared quite a few times. Like this problem was definitely not the first time when I was seeing. And yeah, essentially this is the solution for this problem. Any questions on this one before we move to the next problem? Okay, moving to the next problem then. I won't say well known, but at least this has appeared quite a few times. So like if you have been around for quite a long time, you would have definitely seen this before. And like there are many such tricks over there. Like the idea is you try to find it on spot rather than learning it. Because like this is very specific. If this problem appears, then only you can use it. Although this has appeared probably 3-4 times, but that's fine. And I think this is on probably on lead code as well. You are given an array A of size n. You can arrange the elements of array A as you want. After that, you construct array B of size n, where B1 is 1 and for Bi is B. Like it's basically prefix and of, like you take an array A, you arrange it in the way you want and then take prefix arrays over there. And then it says find the lexicographically largest possible arrays. And lexicograph largest definition also given: two arrays x and y both of size n. Array x is said to be lexicographically larger than array b is the first position where x and y have different values. Xi is greater than yi. So like basically let's look at the problem. Like the idea is we have some array A. So on. Like first we have rearranged it in some way, and then now we have taken like AND of the first array element. Here we have taken A1 and A2. Here we have taken A1 and A2 and A3. A1 and A2 and A3 and A4. And the last element is A1 and A2 and A3 and A4 and A5. It is like this array which we have got over here should be like among all the possible arrays. Like among all the possible arrays, we have to find the lexicographic largest. Lexicographical largest basically means make the first element as large as possible, then make the second element as large as possible, then make the third element as large as possible, and so on. So like if you look at this array, like what is the largest possible value over here? Like the first element is only one value, so the largest possible value for the first element is the maximum of the complete array. So B1 is maximum of complete array. And you can see like for second element, like it has A1 and A2. So what we can do is like following is the greedy idea I have. Then A greater than equal to 1. M is the largest maximum element of A. Push B dot push M, and like replace A with A and M, X and M for all X in A. Like basically the idea is like you find the maximum element, you take it, and because like for all the remaining elements and will be taken with maximum element, so you replace all the elements with the current maximum value, and like if you keep doing it, whatever you get would be the maximum possible array over there. So like a brute force idea. We start with an empty array. While A is not empty, sort all A. Max is A dot back. P dot push back MX. A dot pop back. And now like for all the remaining values we get, the maximum would be taken with this current max. Like the idea is like first, what is the maximum value you can get for the first element? What is the maximum possible value of B1? Like value of B1 would be A1 in the rearrange array. And when we are rearranging elements, we can take the maximum, we can bring the maximum element at the first. Like remember the question said we can only do AND with I minus 1. The idea is AND is taken with BI minus 1. And like, so if you unfold all of this expression, you will get the first element is A1. Second element would be AND of A1 and A2. The third element would be AND of A1, A2 and A3 and so on. So like the first maximum possible value of B1 is the maximum of the complete array. Maximum element of array. Like, is it right? Or like, can you see like why this holds? Like the question, like if you look at it, like it says B3 equal to B2 and A3. And if you unfold B2 again, it will say B1 and A2 and A3. And if you unfold it again, this B1 becomes A1 and A2 and A3. So now you see like why it is taking the prefix maximum. Like brute force, like I will share how to optimize it. Like first my idea was to make everyone realize why brute force should give us the right answer. And then the optimization. So like the first element, like element would be A1. Or like this someone says because AND cannot increase, right? So for example, if we have element, let's say 24 and we also have 16. So if we take 24 and 16, like this element will definitely be less than 16. And like if you take 24 and 8, like this value would definitely, like x and y is always less than x. X and y is always less than y. That's why like B1, the maximum possible B1 is maximum of array A. And now like once we know like the first possible value of maximum, then we have B1 and B2, B1 and B2 and B3. B1 in, let's replace it with 1. Like this we have taken as the max possible value. My idea is like we can replace this mxy. Like basically, if you want AND of m x and y, like it also holds like take individual max with them and then finally take max. Like this holds true. Like if you want AND of three sums, you can individually take the first element, take AND with the other two, and then do the remaining part. So that's why when we know change all of A by taking AND with B1. Like now, like people in the chat, like, do you understand like why does that greedy algorithm works? Like once everyone is on same page, like I will say like how to get away with TLE over here. Like why this greedy algorithm works, like sort all the element, take maximum, put B into the array, put B from the array, and then take AND with maximum. And then like the next part is like if you look at the element, like let's say like you have 4-digit element 1011. So like the first time you take AND, either the number remains same or like one of the some of the ones become 0. So for example, like after taking AND with some number, this number can become 1001. Then you take, if you take AND again, the element can become 0001 and so on. Like basically while taking AND, either value remains same or some bits change from 1 to 0. Why can't we sort all the arrays using some like custom comparator? Like that just makes life easy. Like once you know like from which with which value you have to take, and you just take like change over here. And like once you know this, like the next thing to notice here was like the elements are less than 10 to the power 9, which is less than 2 to the power 31. So there are only 31 bits. So like now the idea is like instead of doing it every time, like find all the times while a dot empty, a is not empty, and then a dot bag is equal to max. Like find how many times maximum appears. This like basically if maximum of the array is 5 and if its maximum appears 5 times, then instead of sorting every time we can just add 5 maximum 5 times and then we do the same thing, and like this will get an AC verdict over here. And this is the idea. Like the main crux of the operation was earlier like we were running this for loop n times. Because of this algorithm, like this main loop runs only 31 times, which is the number of bits, and like here you cannot have more than n elements over here. So overall like the time complexity would be 31 into n into the sorting time complexity whatever here. Any questions on this one before we move to the next problem? Okay, if there are no more questions, then I will move. Yes, like I did all the problems. Time complexity n into 31, and you can probably also add log n because you are sorting here 31 times. So I will move to the next problem then. Yeah, so it says game on rectangle. There is a rectangle of size n cross m with opposite corners as 0, 0 and n, n, and a special point which is in the center of blocks x, y. Two players play a game on rectangle where each player take alternative turn. In his or turn, the player will choose a line either x equal to k or y equal to k, such that k is an integer. Like, can this be solved using try? Like, I did not try solving it by try, and like it's probably an overkill here. And like, and is probably when we try to construct something bit by bit, something which may not work. Two players play a game on rectangle where each player takes alternative turn. In his or turn, the player will choose a line either x equal to k or y equal to k, such that k is an integer. Choose the line. Chosen the line divides the given rectangle into two non-empty parts. The area of rectangle that does not consist of special point is discarded for further move. The player who cannot make a move loses. If both players play optimally, determine the number of special points such that the first player wins. So what the problem statement says to us is, like we have some rectangle. And like we have a special point, let's say here. Now in any turn, player can choose any coordinate axis here. Like let's say a player has chosen this as a line. Now the side which does not contain this special point would be removed from here. Now this side is no longer in play. Now in the next turn, like the next player can choose this line, and like this area would be discarded here. Like players can keep playing the moves. Like in next turn, let's say a player has chosen this line. Then like this area is discarded here. Now in the next turn, like the player can choose this line and remove it. Then like this line. And overall, like this is the only remaining part over here. And now you cannot remove any of the part from here. And like it's asking us, like, let's assume if everyone plays optimally. Yeah, for time complexity one, I will get back to it again. The previous problem. The idea is like once we reach this state where this is the only point, then whoever's turn it is known as the loser. And the like unable to play. And like the problem asks like how many starting points are there. Where first player is the winner. So like any questions on the problem statement? Like any questions on the problem statement of this one? Like I will come back to the time complexity of previous problem again once we are done with this one. So like understood the problem. The idea is like let's forget the story of this. Let's see we are at comma x comma y. So like the number of possible lines on this side is x. The number of possible lines on this side is n minus x. The number of possible lines choices in the starting we have is m minus y. And the number of choices on this side we have is 1. Like these are the starting choices we have for all the possible points. And you see like whenever someone wants to make a move, they essentially decrease one of these numbers. And like they can decrease how many times they want. Like if you choose this, like if this was 5, then the remaining part here would be n minus x minus 5. So like the problem is equivalent to, we have 4 piles of points. First pile has x points. Second pile has n minus x points. Third pile of coin has y points. And fourth pile of coin has n minus y points. And now in a turn, player can choose a pile and remove some number of coins from it. And if all the piles are empty, current player loses. Like, does this make any sense? How does the rectangle problem, like how does the rectangle problem changes into a pile problem where we have so many coins, and like this is the game we are playing? Like any questions on this equivalent idea first? Now like probably something I won't prove. Like this is called NIM game. Like this setup is called this setup, and like winning, like first player loses. First player loses only if XOR of all piles is 0. And like this is the result I won't prove. You can probably read Wikipedia page for the proof. And by the one nitpick, like this should probably be x minus 1. This should be x minus 1, y minus 1, y minus 1. Like these are the number of choices you have, not x minus 1 possible choices you have in the starting. Because you cannot keep the value as it is. And like this is the result which I won't be proving. And probably you should read out the problem here. Like LeetCode also has this problem in game. Like you are initially playing the nim game with your friend. Initially, there is a heap of stones on the table. You and your friend will take alternative turns. You go first. On each turn, the player removes. Like it's a bit of different nim game. Like mine was general nim game. Yeah, probably. And like once we know this result, what it asks us is like count the number of coordinates where like the XOR would be 0. Like basically, the problem reduces to counting x minus y, XOR, n minus x minus 1, XOR, y minus 1, XOR m minus y minus 1 is 0. And what we can do is like we can first count all the possible values over here of x minus y XOR. We can compute all the possible pairs in set here, and we can also compute all the possible values over here. And then we can count like for all the values which are present in both the cell, multiply how many times they appear. And like that would be essentially the solution for this problem. So like I have a method getGrundy which takes a length n, and it gives us like what are the possible values of XOR of two numbers we can get if we can take like both of them should be at least 0 and something like that. So like if we start with first coordinate as k, like x equal to 1, x less than n, like the if we take the like the opposite side would have n minus x minus 1 possible sides over there, and like the XOR of both of them would be this. Like minus 1 is there because like if you are on x equal to 1, then you cannot play any move on the left hand side, so you are it's equivalent to 0 coins on that side. Or if you are on x equal to 2, you can remove value only once, so it's equivalent to having only 1 coin there. So like I take all the possible values over there and all the possible Grundys over there, and because we want first player to win, so like the only time when first player loses is when XOR of both the elements is 0. So like now like this is are the total number of choices, and now we can subtract how many times the first player loses. For all the elements which are in A, if that element is also in B, then multiply like both of the time how many times both of them appear. And like that was essentially the solution for this problem. Any questions on this one before we move back to the previous problem for the time complexity? And like this was the solution for this problem. Okay, like Main crux of this problem, 1 second, like not the mod one. The crux of this problem was, let's count how many times the outer loop runs. Like my claim was like this outer loop runs only 31 times. And like something in this sorting takes n log n, and like removing you cannot remove more than n elements. So overall time complexity is count outer loop into n into log n. Like, does this make any sense? Like, why this should be the maximum time complexity we can have? Count how many times the outer loop is run and into n log n the value inside it. And like the next question is like, and see, like the test cases also pass. For all the test cases, it's less than 30. The critical question is like, why this is always less than 31. So like one thing you can notice is like, whenever we run this loop, new maximum is less than the previous maximum. And in fact, like the new maximum is and with the previous maximum as well. The idea is, if we have some number like 10101 and we take AND with, for example, 1010111. If we take AND of these two numbers, the new number becomes 1 0. This gets away. 0 0 0. This one remains 0 and this one also remains 1. And like every time you run an iteration, like one of this one will be removed from this the previous number you have. And because there are only 31 bits over here, you cannot remove more than 31 times. And now if you take some more and over here, the new number becomes so on, and we can keep going it. Any questions on this problem now before we move to the next problem? So like I will probably move to the next problem then. Sum of max k subarray. Like among these three problems, like I found this to be the hardest one, to be honest. Although the number of ACs say otherwise. So it says sum of max k subarray for a permutation p of size n and integer k. Let's define f of pk as sum of all consecutive kk segments over here. Let g of nk be the number of permutations of size n which are maximum possible value f of pk. Given, and find the value of g of nk for each of them. Since the value can be large, print it mod this. And permutation definition and everything is given. So the problem statement says, like let's say we have this as a permutation. And n equal to 5, k equal to 3. Then like this would be the first array. This would be the second array you can get. And like this would be the third array you will get. Take maximum of all of them. 4 plus 5 plus 5, which is 14 here. Similarly, if your permutation is 2, 4, 5, 3, 1, maximum first array is 5, maximum second array is also 5, and maximum of third array is also 5. So it would be 5 plus 5 plus 5, which is equal to 15. And like you can verify that you cannot get more than 15 at any point of time. So it asks us to find like the count of all the permutations where the maximum sum would be 15 here. Any questions on the problem statement? And once you know the problem statement, first question is what is the maximum value we can get? My claim is like, let's say we have n equal to 10, k equal to 3. What I can do is like, I can replace first numbers, like this is the first array, right? So like I would place the largest number at the end of this array. And now you can see like this 10 is covered in the second segment as well, and this 10 is covered in the third segment as well. And now like this would be the first time a new array comes in where the max is not 1. Then I can put 9 here. 9 will be covered 3 times. Then I can put 8 and so on. And once all the maximums are decided, I can place the remaining numbers in any order I want. So my claim is like 10 can appear at max k times, 9 can appear at max k times, while count remain like as long as the segments remaining are more than 1. Number of segments we can get right now, which would be minimum of k and count remain whatever remains there. This would be the time we can get maximum. Then we do max minus minus and count remain minus equal to c. Like you can write this algorithm to get the maximum sum over here. And now the idea is like how do we count over all the permutations such that this sum is maximum there. Like the idea is still same. Like we can say that in a starting position the max is n, like we can divide it in some blocks there. Like for example, we have n equal to 10 and k equal to 3. 10 would appear 3 times. Total number of arrays will be n minus k plus 1, which would be 8. Like this should be n minus k plus 1. So you say like 10 would be there 3 times, 5 remains, 9 would be there 3 times, then 2 will remain, and then 8 would be there 2 times. And like this would is the maximum you can get. One possible idea is you put it in blocks like this. Like these are the starting indexes. So first 3 elements 10, second element 9, third element 8, and like these two, like this is the order. Now if you fill remaining places in any order, like you will get the maximum answer. The other thing to notice here was like this 8 can also be moved here. Like then also like this block will contain 8 and the next block will also contain 8. So first let's look at all the starting points. Like wherever 10 appears, it would be like 3 consecutive starting positions. Wherever 9 appears, there would be 3 starting positions. And wherever 8 appears, like it would be 2 starting positions. So if 8 is in the last 2 buckets, so like first we can find the order of these maximums appear. Like it can also be possible like in the first 2 arrays 2 times 8 appears. Then in the next 3 times 10 appears. And in the next 3 times 9 appears. Like this is also allowed here. Like any questions on the idea so far, like before I proceed on the next possible optimization? Because like each index in the starting is a part of at most k elements. So if you pick the first element, put 10 there. Like once we know this, and like the next part is like let's also observe like how 8 appears. If 8 appears in the first 2 indexes, like this would be the first array, and this would be the second array. So in fact you have 2 choices for 8, so you can place 8 here as well. And like this is essentially the idea. Count the order like where the largest element would be placed. It's possible that among all the largest elements, smaller elements can have multiple choices. So place it there as well. Once we have figured out these places, all the remaining elements can be placed any number of times. So like if k is n or k is 1, choose any order. Like in case of k equal to n, you have only valid one array and the answer is n. And if k is 1, like the answer would be sum of all the elements. Order does not matter. So return factorial of n. Now count how many large elements we need. Number of starting position is n minus k plus 1. And each element can be part of at most k elements. This would be take seal. Short segment length, like which is basically like starting points. Like now, like only one of the element can be less than k. Like so, this is the short segment length. Short segment length is equal to 0 is essentially saying all the elements are equal. In this case, the answer is largest element in short segment, which would be k minus and now like for like all the starting large required, like you can decide the order of relative order of all the large elements, and once you have placed all the large elements, like fact is factorial over here, you can place all the remaining elements here. And if short segment is 0, it's essentially saying like all the elements appear k times. So the idea answer in that case would be like the number of large elements you need, what you can decide the order between them, and like all the remaining elements. And essentially this was the solution for this problem. Now you can find the value for all given nk. Like fact is the factorial, we don't need LCR. Like I have pre-computed all the factorials here. Any questions on this one before we move to the next problem? Looks like I ended up writing numbers multiple times. So this was my solution for this problem. Any questions on this one before we move to the next problem? I don't know why there are some compilation errors. Like, it's mostly because the library I am using. The problem is SUMMAX. Wait. Or like there was a typo there. Yes. Any questions on this one before we move to the next problem? Non-zero XOR and minimum segments. Non-zero XOR is similar to the previous problem. Earlier we were taking AND of all the segments. Now we are taking XOR of all the segments. And it has asked us to rearrange such that none of the elements in B is 0. And if multiple possible exist, we can print any of them. If none of them exist, we should print -1. So regarding the solution part, if XOR of all segment is 0, then irrespective of how you arrange, Bn will always be 0. So print -1. This is one possible case where the answer is impossible. Another possible case is like only one element appears here. Like all the numbers are same. In that case, XOR of first number would be that number, XOR of second number would be 0, third is X, fourth is 0, and so on. So that is the impossible case. When n greater than 1 and all elements are same. So like these are the only impossible cases. I took all the numbers as input, sorted them, and took XOR of all them. If XOR of all of them is 0, print -1. If we are sorted and the smallest and the largest element is same and the number of elements are more than 2, print -1. These are the only two impossible cases. Otherwise, the answer always exists. And like either like one possible case is do casework. Or like the another solution was realizing that like the idea is like first we place elements however we want. Like we decide whatever the order is, A1, A2 up to AK, and XOR so far is BK. The only condition is like the next number should not be equal to BK. So what we can do is like we pick a random number, we put it in our array, and we see like what is the XOR of, as long as like the XOR at the current element does not become 0, we keep putting it. So like for example, if XOR of first 10 elements is 5, then on 11th number you cannot keep 5, but if you keep any other number, the XOR would be more than 0. So keep doing this part. And the idea is like you would be able to arrange numbers in some way. Like some arrangement you would be able to put. XOR over here would be BK. Let's say XOR of these 5 is some B5. And the place where you will stuck is all the remaining elements are equal to B5. And like for a minute, let's assume that none of the element is 0. Like all the elements in fact are positive. So what we can do is like you can probably notice like this element will not be equal to BK, because had this A5 equal to B5, then XOR of these elements will become 0. So what you can do is like you can insert all the elements just before where you are stuck, and like this should essentially solve the problem for you. And like keep inserting any element which is not equal to the XOR so far. Like some people maintained a set like you can also use multiset. So like the reason I am using multiset is so like instead of picking the random, I will pick small and large, but picking random also works. While the multiset is not empty. If current XOR when you take with menu, if the element becomes 0, then instead of min take max. If current XOR is not equal to 0, like you should be a bit careful. Like be a bit careful on how you delete elements with bitwise. If you take the current min and XOR becomes 0, then take the maximum element. If XOR becomes non-zero with the max element, then put B as the max element. Otherwise, you can prove that all the elements are equal to max. So what you can do is find the last element, remove this last element, and insert all the numbers in current set in the back. Now insert last element back here and print whatever, essentially this is the solution. The idea is keep picking random element such that that is not equal to current XOR so far, so that current XOR does not become 0. And once you are done with picking the random elements, there would be a case when XOR of all the elements you have picked is equal to all the remaining elements. Let's say you have picked the first 10 elements, XOR of them is 5, and only 5 remain there. So if you pick any element, 5 will come here. So the idea is just remove the last element, put all the elements just before it. Because this is not equal to this, so like the XOR of, because this element is not equal to 0, XOR of first 4 elements will not be equal to BK. It would be something different. And essentially that is the idea. Any questions on this one before we move to the next problem? And that would be the last problem for today. Like I took min and max because that made my choice easier, but you can also pick random and the same logic will work. So like the last correction was the tricky part. I think otherwise people would have tried solving the rest of it. So like the next problem is a bit trickier. It says you are given string S of length n consists of all the lowercase Latin letters of from A to Z, A to T. A string is called good if frequency of all the characters present in the string is odd. For example, the string AABA is good as there are two characters A and B with frequency 3 and 1, both of which are odd. The string BCB is not good because the frequency of character B is 2. Find the minimum integer k such that the following array exists. So like the problem statement is essentially saying first a good string is defined. All the characters present are odd number of times. And the second part is essentially saying we have been given some string S. We have to split it into some number of strings, substrings, such that all individual strings are good. Total split is minimum possible. Any questions on this one? Any questions on the problem statement or what it asks us to do? At this point, some order n square brute force should come to your mind. So like if you take the sample in the first sample, A, B, C can be the first string and B, D can be the second string. In the third sample, A, B, C, D can be one of the string and A, D, D. No, wait. Why is answer 2 over here? Okay, you can take this as one string and this as the other string. So like once we know this, the first DP idea that comes to our mind is DPR is like minimum number of partitions where we have split string 1 from 1 to R. And DPR would be 1 plus minimum value of DPL minus 1, where string from string L to R is good. This is the brute force idea we will have. Like basically find the left starting point. So find the number of split just before that and take the current one string as the split. Like how do we check if a particular subarray is minimum? So like my idea was, first we maintain bit mask of size 26. Like basically each character is a bit. So if A appears, we toggle the bit 0th bit. If C appears, second bit. So basically, like if we look at it, A, B, C, A, C, D. If this is the character, like we can first create a prefix XOR here. Like basically the first number would be 0. If we take 1, we take 0 XOR 0, 1. For B, we take the second bit, so we take XOR with 2. So the number is 3. For C, like it would be the second bit, so we take XOR with 4. For A, we flip the first bit again. For C, we flip the second bit. For D, we flip the 14th bit. So like if we flip ith bit. So now if you have some array, if you take some array from L to R, XOR ref L minus 1, you can calculate in order 1 which characters appear odd time, which characters appear even time. And which characters appear even times. Any questions on this part so far before we do further optimizations here? Like if ith character denotes ith bit and we create a prefix XOR where for whenever the ith character appears we toggle the ith bit, then by if we want to count from the string from L to R how many characters appear odd times, how many characters appear even time, we can take XOR of these elements. So what we can do is like similar to like the AND part before, when we want to count DPR, like this array can be divided into some segments. Among this part, one distinct element would be there. In this part, two distinct elements would be there. Like there would be some ranges like this. And like based on which index you are, you would be able to find like what all characters are there. So the idea is like if we know pref all, so which characters are present, then we can find mask related to it, and we can find minimum value of dp L minus 1 where pref L would be equal to m XOR ref and like this part is probably like now you have some ranges. In some ranges you have some different prefix sums. Your queries of form I give you a prefix or and a range. Find what is the minimum value for at all the places where that prefix or appears in this range. What is the minimum DP value you can get? And like here you can probably use the segment tree where in each node you maintain all the elements. And like you try out all the possible 2026 segments like this where only one distinct value is there, only two distinct values are there, only three distinct values are there, and so on. And like this was mostly the solution for this problem. Like I think I probably hurried it a bit, but I think this updates is the segment tree which takes a particular index. It takes like ref mask and it takes DP value and it inserts it there. So like a normal segmentary type of code, like where range L2R contains all the mask in that range and what is the minimum DP value there. And similarly, we have query as well, where we have a range, we have some mask, and we want like the minimum value we will get of the DP value if we look at that mask. Similar, like each node of a segment tree contains a map here, and it will traverse the segment tree count all the places where minimum value appears. In starting DP0 is 0 and the mask so far is 0 as well. We have also calculated prefix mask like this. Character C, toggle the state bit and take everything else. Like I also maintain like most, like for each character I maintain the most recent index. If we are at character C, then SR's the character at SR most recent index would be R. Then I have some like all the distinct values of most recent index, and then I iterate it on them. And like between all these values, like I will know how many values are there. From GJ -1 to GR, like the number of distinct values in this segment would be same. And like I can iterate on this mask to see like if most recent index is greater than equal to 3, that is the character we want. Required RFL. Like this essentially takes all the segment which are starting index and appear in that. And now the query is like among all the prefix JAWS from L to R-1 because the starting index would be R. And which have this prefix value, find the minimum value, add 1 to it, and that would be the current minimum count. And once we are done with it, we also update this over here. Like we don't really need this update for 0 though. Like this is essentially the solution I had for this problem. So I think with this, I am done with all the problems. Any questions on any problem or something that was not clear before we close today's stream? although like this takes 1.58 seconds, pretty close to the 2 second time limit. But yeah, that was the solution I had. So like any other questions or anything before we call it a day? Thanks everyone, whoever is here so far, for joining today. I'm planning to do Code Forces contest stream, tomorrow's contest stream as well. So like thanks a lot everyone for joining today.